the chapter function, we will do types of function. We will see so many types of function today. They are possible graph as well as domain and range. About the domain and range, you have already know domain means input of the function. In terms of x and y, we will say values of x for which function is defined, function exists. So domain means values of x for which graph is possible. ग्राफ कितने x के लिए ड्रॉ हो रहा है, that is called domain. Range, set of values of the function corresponding to values of domain, and range is found on the y-axis. So in terms of graph, range on y-axis and domain on x-axis. On the x-axis, for what values of x, graph can be drawn, that is domain. On the y-axis, values of y corresponding to graph is called range. So we are going to study types of functions. Types of function, and the first type we are going to take polynomial function. Polynomial function, function a function f of x of the form a naught x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2, in this way up to n, where n belongs to natural number. This is called polynomial function. Function in terms of power of x. Function having expression in terms of power of x, where all the powers are whole numbers. Domain is R, range it is also R. If we are talking about standard polynomial function, domain is R, range is also R. An important note regarding polynomial function which will help you in solving the problems: if f of x is a polynomial function satisfying f of x plus f of 1 by x is equal to f of x into f of 1 by x, then f of x is equal to 1 plus minus x to the power n. Student, इस रिजल्ट को नोट कर लीजिए. It will helpful in solving the problems. Polynomial function satisfying the formula relation f of x plus f of 1 by x is equal to f of x into f of 1 by x. Then f of x is equal to 1 plus minus x to the power n. Other than this function, nobody will aggregate. If this condition is given, directly you can go with function 1 plus minus x to the power n. Now, number 2 is rational function. What is rational function? A function f of x ratio of two polynomial. P of x is equal to q divided by q of x, where p of x and q of x both are polynomials. So ratio of two polynomial is our rational function. Ratio of two polynomial is a rational function. Number 3 is linear function. We can also say linear function is a type of polynomial because the least polynomial will be linear. But especially I am taking this one just to remember graph. We will draw some graph here. So linear function is f of x is equal to ax plus b. F of x is equal to ax plus b. Examples: f of x is equal to x, f of x is equal to minus x. Diagram for f of x equal to x, f of x equal to minus x. F of x equal to x, f of x equal to minus x. Then number 4 we have identity function. F of x is equal to x for all x belonging to domain. Now student, don't get confused between linear and identity. For linear function there can be so many examples out of those. F of x equal to x is one example for linear. But in case of identity, only and only function is f of x equal to x. F of x equal to x यहाँ भी दिख रहा है, यहाँ भी दिख रहा है. For linear, so many example. One example is f of x equal to x. Identity, only and only f of x equal to x. No other example for identity. Only and only f of x equal to x. Number 5 is modulus function. Modulus function, f of x is equal to mod x, further which can be written x if x greater than or equal to 0, minus x if x less than 0. This function is called modulus function. You must know this symbol. This is the symbol of mod. The mod of x is called modulus function, which is x when x is positive minus x when x is negative. We can draw the graph for modulus function. So for positive x, we have to take line of x. For negative x, we have to take line of minus x. This is line of x, this is line of minus x. So diagram of modulus function. Modulus function is f of x equal to mod x and we have this graph. Now, graph ko dekh कर we can comment on domain and range. Domain, range. From a graph, how we find the domain? All the values of x for which graph is possible. That is called domain. So here all the real number. Range on the y-axis. On the y-axis values of graph is called range. So here is it. It is square bracket 0 to infinite. 0 is also coming. आप में से कई लोग बोलते हैं रेंज विल बी आर प्लस, दैट इज रॉन्ग. आर प्लस में जीरो नहीं आता. हेयर ग्राफ इज गिविंग द वैल्यू फ्रॉम जीरो अप टू इनफाइनाइट. तो जीरो टू इनफाइनाइट वेयर जीरो इज इंक्लूडेड. सो स्क्वायर ब्रैकेट जीरो टू इनफाइनाइट. So our modulus function f of x equal to mod x, and that is graph of modulus function. Student, here I am also telling you some properties. Properties of mod x ये आपको हेल्प करेगी प्रॉब्लम में. नंबर वन, mod of xy, mod x into mod y, mod of x upon y, mod x upon mod y. Number three, mod of x plus y less than or equal to mod x plus mod y. Number four, greater than or equal to mod x minus mod y. Number five, mod of a number is always greater than or equal to that number. Mod of a number is always greater than or equal to that number equal when number is positive or zero, greater when number is negative. Number six, mod x is equal to a implies that x is equal to plus minus a. Number seven, mod x less than a implies that x lying in between minus a and plus a. Number 8, mod x greater than or equal to a implies that x less than or equal to minus a or greater than or equal to a. Remember, they are true only when a greater than 0. Okay. So these property will help you in a problem having mod sign. Mod equal to some number, mod less than some number, mod greater than some number, and this fifth one, this is too much important, mod greater than or equal to mod of a number greater than or equal to that number. When it is equal to number, when it is greater than number. Okay. So now, types of function. We are talking about types of function. We have started with polynomial, then rational, then linear, then modulus. Now, number 5 is signum function. It is f of x is equal to SGN, which is x upon mod x when x not equal to 0 and 0 when x is 0. This definition can be further written as 1 minus 1 0, 1 when x is greater than 0, minus 1 x is less than 0, and 0 when x is 0. Diagram of signum function. One for positive x, minus 1 for negative x, and 0 at 0. Students, इस ग्राफ में ध्यान दीजिएगा. I have drawn arrow sign dot. When we draw dot, when we draw arrow sign, now that you have to understand. In this graph, if I ask about value of the function at x equal to 0, what will you do? आपको 0 पे 0 दिख रहा, but 0 के ऊपर 1 भी दिख रहा, 0 के ऊपर -1 भी दिख रहा, तो there will be a confusion. तो simply what we follow, at the time of drawing a graph, if particular value is to be taken, we put dot, not to be taken, we put arrow. For example, डेफिनेशन कहती है कि 0 पे वैल्यू क्या लेनी है? 0. अब जब आपने डायग्राम बनाया तो आपको 0 पे 1 भी दिख रहा, -1 भी दिख रहा, 0 भी दिख रहा. लेना क्या है? 0. तो स्ट्रिक्टली 0 पे डॉट रखा और 1 और -1 पे एरो रखा. तो इट इज इंडिकेटिंग दैट कि हमें 0 पे 1 और -1 वैल्यू नहीं लेनी है. एट 0 वी विल टेक ओनली एंड ओनली 0. नाउ डोमेन एंड रेंज. डायग्राम को देख के बताइए. डोमेन, ऑल एक्स, रेंज. In the name of range, we are getting only 3 elements, -1, 0 and 1. In the name of range, we are getting only 3 elements, -1, 0 and 1. So range is set of -1, 0 and 1. While domain is all the real number, range it is set of -1, 0 and 1. Student, I am writing a note here. Remember, x upon mod x is equivalent to mod x upon x. X not equal to 0. ये मैंने इसलिए लिखा, in the name of definition what I have written, signum x is x upon mod x. If anywhere you get mod x upon x, so remember both are same, so don't be confused. X upon mod x is same as mod x upon x. So for the definition of signum, if you get mod x upon x, that is also correct. I have taken x upon mod x, but there mod x upon x will also work. After signum, now the next important function we have, we are coming to number 6. It is greatest integer function. And write important for it. It's a very important type of function. पूरे क्लास 12 के सिलेबस में बार बार आपको ये मिलेगा. Greatest integer function. How is it denoted? What is the symbol? X inside the square bracket. This is the symbol of greatest integer function. As we know about mod, mod का symbol हमें पता है. mod का symbol क्या होता है? 2 vertical line. So similarly, greatest integer has symbol square bracket. X inside the square bracket, it is called greatest integer function. Okay. Definition पे आते हैं. How to define it? So अगर definition की बात करें तो बोला जाता है square bracket x is equal to x if x itself an integer, otherwise an integer just before of x if x doesn't belong to an integer. डेफिनेशन में ध्यान दीजिए, x integer, x doesn't belong to an integer. Square bracket x is x, an integer just before of x. Better to remember in this manner, whatever number quantity is written inside square bracket, same will be output if that is itself an integer. Output will be integer just before of input if input is not an integer. Greatest integer has symbol square bracket. If we talk about definition in terms of input and output, अंदर वाला input अगर खुद integer है तो सेम टू सेम बाहर आ जाता है. अंदर वाला input non integer है, then as an output we get number, we get integer just before of input. We are taking some examples. I have square bracket 2. So 2 is what? Integer. Same will be output. 5. 5 is integer. Same will be the output. Minus 3. Minus 3 is integer. Same will be the output. 0. 0 is integer. Same will be the output. Now I'm taking 2.1. 2.1 non-integer. 2.1 is what? 2.1 is non-integer. The output will be the integer just before of 2.1. That is 2. 2.4. Non-integer. Output will be integer just before of 2.4. That is also 2. 2.4 के पहले integer क्या होता है? 2 होता है. 2.9 जानबूझ के मैंने लिया है कि आप में से कई इसमें गड़बड़ करोगे. 2.9 का स्क्वायर ब्रैकेट विल बी एन इंटीजर जस्ट बिफोर ऑफ 2.9. क्या होता है? 3 होता है कि 2 होता है? अगेन 2. आप में से कई लोग यहां का आंसर 3 देते हैं. वाई 3? इट इज नॉट द राउंड फिगर कॉन्सेप्ट. स्क्वायर ब्रैकेट हमें वैल्यू देता है इनपुट के पहले वाला इंटीजर. तो 2.9 के पहले इंटीजर क्या होता है? 2 होता है. 0.5 what will come? 0. Minus 1.7 what will come? Minus 2. Minus 2.9 what will come? Minus 3. Fine. So in this way square bracket work. So now we will make the diagram. Diagram of greatest integer function. Fine. So in this way we get the diagram of greatest integer function. Once again I have used dot and arrow. Dot वैल्यू अगर लेनी होती है तो डॉट का यूज करते हैं, नहीं लेनी होती है तो एरो का यूज करते हैं. फॉर एग्जांपल मैं आपसे बोलूं कि 2 पे ग्राफ की वैल्यू क्या होगी, तो आप क्या करोगे? आप 2 के करस्पॉन्डिंग अप एंड डाउन ग्राफ की वैल्यू देखोगे. तो जब आप 2 के करस्पॉन्डिंग देखते हो तो आपको एरो भी मिलता है, डॉट भी मिलता है, तो देयर विल बी अ कंफ्यूजन, किस वैल्यू को ले? अकॉर्डिंग टू द डेफिनेशन 2 का स्क्वायर ब्रैकेट क्या होगा? 2 होगा। तो व्हेन आई एम टॉकिंग अबाउट वैल्यू एट 2, तो मुझे किसके साथ जाना चाहिए? 2 के साथ जाना चाहिए। तो इफ देयर आर डॉट एंड एरो, तो देयर विल बी नो कंफ्यूजन और आप सही वैल्यू के साथ जाओगे। आपसे कहा जाए ग्राफ को देखकर 3 पे वैल्यू बताइए, तो आपने 3 के ऊपर देखा, एरो भी दिख रहा, डॉट भी दिख रहा, आप किसके साथ जाओगे? डॉट के साथ। और डॉट के साथ जाओगे मीन्स व्हाट? 3, विच इज करेक्ट। इज इट एनी कंफ्यूजन कि हाउ इज दिस ग्राफ कमिंग? सो सिंपल। 0 से 1, 0 से 1 के बीच में जितने भी x है, 0.1, 0.2, 0.3, 0.4, सभी का स्क्वायर ब्रैकेट क्या होगा? 0। तो वी आर गेटिंग लाइन ऑफ 0। ऑल द x बिटवीन 1 एंड 2, 1.2, 1.3, 1.4, सभी का स्क्वायर ब्रैकेट क्या होगा? 1। तो करस्पॉन्डिंग 1 to 2 वी आर गेटिंग लाइन ऑफ 1 एंड सिमिलर वे। नाउ ग्राफ को देखकर डोमेन और रेंज बताइए। व्हाट अबाउट डोमेन? All the real number. What about range? Range is I. I means set of integer. So in the name of domain, all real values of x, while in the name of range, all the integers. Range कहाँ पाई जाती है? y-axis पे, and on the y-axis we are getting integer. तो range is set of integer, domain is set of real numbers. So dear student, now we will study properties of greatest integer. Property number 1, square bracket of a number x is always an integer less than or equal to that number. It means square bracket will always be an integer less than or equal to that number. We can further explore it. Square bracket x is equal to x if x is integer, less than x if x is not integer. Okay. So square bracket x less than or equal to x, out of that equal to x when x is integer, less than x when x is not an integer. Now property number 2, square bracket x plus square bracket of minus x is always 0 if x is integer, minus 1 if x is not an integer, 0 if x is integer, minus 1 if x is not an integer. Number 3, square bracket x plus y is always square bracket x plus square bracket y if at least one of x or y is an integer. Okay. So according to this property, sign of greatest integer get distributed, but only and only when out of x or y at least one is an integer. x और y में से कम कोई एक integer होना चाहिए. Only then we can distribute the sign of greatest integer. You can also write square bracket x plus minus I is equal to square bracket x plus minus I. If we have conformally integer, inside the square bracket, either in addition or subtraction, it get out, बाहर निकल आता है. x plus minus I, where I is an integer. Here I is an integer. So square bracket x plus minus I is square bracket x plus minus I. If there is integer inside the square bracket, it will directly come out. Number 4. Square bracket x is equal to I implies that x in between I and I plus 1. Remember, I is an integer. Square bracket x equal to 2. So what can be x? X can be 2 to 3, that I have written. Square bracket x less than I. Square bracket x less than I, student, easily you can write the result assuming some integer in place of I. Let's say 2. Square bracket x less than 2. Square bracket x less than 2. So what can be square bracket itself? Square bracket x less than 2. Square bracket क्या होता है? Integer होता है. देखना. Square bracket x less than 2. So what will we take in place of in terms for the values of square bracket? 1, 0, minus 1, minus 2 and so on. Square bracket less than 2. Square bracket is always an integer. तो less than 2 के नाम पे square bracket क्या होगा? 1, 0, minus 1, minus 2 and so on. No. Square bracket equal to 1. Square bracket equal to 1. So what about x? X 1 to 2. Square bracket 0. What about x? 0 to 1. Square bracket minus 1. What about x? X minus 1 to 0. So in terms of x, we are getting the result what? 2 to 1, 1 to 0, 0 to minus 1. So continuously we are going below 2. So square bracket x less than I implies that x less than I. Square bracket x less than I implies that x less than I, where I is an integer. Similarly, we can write other results. Square bracket x less than or equal to I. Square bracket x less than or equal to I. Once again, you can assume some integer in place of I. Let's say 2. So square bracket x less than or equal to 2. So what will be the values of square bracket? Square bracket equal to 2, square bracket equal to 1, square bracket equal to 0. Now corresponding values of x we will find. Square bracket x equal to 2. What about x? 2 to 3. Square bracket x equal to 1. What about x? 1 to 2. So we are getting the values 3 to 2, then 2 to 1, then 1 to 0 and so on. So this time I am writing x less than I plus 1. Square bracket x greater than I. Square bracket x greater than I. इसको भी एक एग्जांपल लेके करके देखते हैं. Square bracket x greater than I. मैंने I की जगह 2 लिया. मैंने I की जगह 2 लिया. तो square bracket x greater than 2 means how much square bracket? Square bracket 3, 4, 5, 6 and so on. Now, if square bracket is 3, so what about values of x? 3 to 4. Square bracket is 4. What about values of x? 4 to 5. Square bracket is 5. What about values of x? 5 to 6. So this time you can see we are getting the values greater than or equal to 3. 3 से 4 गए, 4 से 5 गए, 5 से 6 गए. When we have taken greater than 2, we are getting the values of x starting from 3. So greatest integer x greater than I, what will it imply? X greater than or equal to I plus 1. Getting students? ये मैं आपको इसलिए करके दिखा रहा हूँ, whenever you get confused, आप एग्जाम्पल लेके तुरंत रिजल्ट निकाल सकते हो. Now number 8, square bracket x greater than or equal to I. Do it. Tell me the result. Square bracket x greater than or equal to I. Square bracket x greater than or equal to I. I की जगह 2 ले लिया. तो square bracket x greater than or equal to 2 means square bracket equal to 2, square bracket equal to 3, 4. Square bracket equal to 2 means x 2 to 3, x 3 to 4. So what will be the result? Result is x greater than or equal to I. X greater than or equal to I. So these are all properties of greatest integer function. All of these will help us in problems. Fractional part function. How is it denoted? What is the symbol? Curly bracket. In case of greatest integer function, symbol was square bracket. Here in fractional part function, symbol is curly bracket. X written inside curly bracket. This is called fractional part function. देखो इससे previous one was greatest integer, उसके नाम में क्या था integer, तो रिजल्ट भी कैसे आ रहे थे integer. Here नाम में क्या है fractional part, so आने वाले रिजल्ट क्या होंगे फ्रैक्शन होंगे. सही बात है, ऐसा ही होता है. डेफिनेशन की बात करें, सो डेफिनेशन curly bracket x is equal to x minus greatest integer x. From a number, if we subtract its greatest integer, we get the fractional part. Number minus greatest integer give us fractional part. Let us do some example. Curly bracket 2 will be how much? 2 minus square bracket 2. बताइए कितना होगा? It will be 0. 2 का स्क्वायर ब्रैकेट क्या होता है? 2 होता है, तो 2 minus 2 0. Curly bracket 3 will be 3 minus square bracket 3. Now 3 का स्क्वायर ब्रैकेट 3, तो 3 minus 3 0. Curly bracket 2.7 will be 2.7 minus square bracket 2.7. Tell me this one. 2.7 का स्क्वायर ब्रैकेट 2, तो 2.7 minus 2, what's the answer? 0.7. Some more examples. Curly bracket 5.1, how much? 5.1 minus square bracket 5.1. 5.1 का स्क्वायर ब्रैकेट 5, what's the result? 0.1. Curly bracket minus 3, it will be minus 3 minus square bracket minus 3. So minus 3 का स्क्वायर ब्रैकेट minus 3, result is 0. Curly bracket minus 1.7, how much? Minus 1.7 minus square bracket minus 1.7. Now square bracket minus 1.7, how much? Minus 2. So minus 1.7 plus 2, what's the answer? 0.3. So if we check all the results, you can see out result is either 0 or a fraction. Result is either 0 or a fraction. For fractional part function, result is always either 0 or a fraction. Now we will make graph. Graph of fractional part function. So dear students, in this manner we get graph of fractional part function. Important thing, these line, we are getting the graph in terms of inclined lines. You must remember equation of these lines, x minus 1, x minus 2, here x plus 1, x plus 2 and so on. So this will help you in problems. Diagram of fractional part x in terms of inclined lines, and each line has a different equation. Here on the right hand side x, x minus 1, x minus 2 and so on. On the left hand side x plus 1, x plus 2 and so on. Now, from the diagram, we can write domain as well as range. So tell me domain. What is domain? It is clearly set of all the real numbers. Range. On the y-axis, what's the minimum value? 0. And what is the maximum value? 1. But dear students, ध्यान से देखो 1 पे क्या आ रहा है? Arrow. It means what? ग्राफ हमारा 1 को रीच कर रहा है बट 100% 1 नहीं हो पा रहा है. So at the time of writing range, 1 has round bracket, 0 has square bracket, 1 has round bracket. That means 0 is included in the range but 1 is not included. Properties. Properties of fractional part function. Number 1, curly bracket of integer is always 0. Number 2, x plus minus I inside the curly bracket is simply curly bracket x. Means if we have integer inside integer in plus minus inside the curly bracket, it will directly get disappear. Greatest integer में देखा था integer बाहर आ जाता है, but here in case of curly bracket it directly disappear. Involving greatest integer curly bracket. स्टूडेंट्स टाइप्स ऑफ फंक्शन के बीच में ही अब मैं आपको एक इंपॉर्टेंट चीज बता रहा हूं, हाउ टू सॉल्व द इक्वेशंस इन्वॉल्विंग स्क्वायर ब्रैकेट कर्ली ब्रैकेट. सच काइंड ऑफ प्रॉब्लम यू मे हैव इन द एक्सरसाइज. आई एम टेकिंग द प्रॉब्लम. वी हैव टू सॉल्व 4 times curly bracket x is equal to x plus square bracket. Okay, now this we have to solve. So what I am telling you, in such kind of problem always assume x is equal to I plus f. X is equal to I plus f, where I is integer and f is a fraction having the value in between 0 and 1. I is an integer, f is a fraction having the value in between 0 and 1. Now put them in equation. So 4 times curly bracket of I plus f is equal to I plus f plus square bracket I plus f. Now curly bracket I plus f will give f, square bracket I plus f will give I. So in this way 3f is equal to 2i, f is equal to 2i by 3. Now since f in between 0 and 1, so 2i by 3 in between 0 and 1, so I in between 0 and 3 by 2, it implies that I is equal to 0 and 1. Students, are you getting it? We are talking about solution of equation involving greatest integer fractional part. So let us assume x equal to I plus f, where I is integer, f is a fraction. Since f is a fraction, its value will be in between 0 and 1. I have got the relation between f and I. Now using the point f in between 0 and 1, I am able to decide the value of I. Now f is equal to 2i by 3. F is equal to 2i by 3. Since f is equal to 2i by 3, so I is equal to 0 implies that f is equal to 0. I is equal to 1 implies that f is equal to 2 by 3. Now I am going to write the answer. So x is equal to 0 plus 0 and x is equal to 1 plus 2 by 3. So 0 and 5 by 3. Zero and 5 by 3, these are my two answers. X is equal to 0, x is equal to 5 by 3. So whenever you get an equation where you are finding greatest integer as well as fractional part, this is the best approach to handle the problem. Assume x equal to I plus f, I is integer and f is fraction. So students, now in type of function we have type number 8, it is logarithmic function. आप सभी लोग इसका नाम सुना हुआ है, आपने जानते हैं, f of x is equal to log of x. F of x is equal to log of x, and this number written in the subscript, it is called base of the log. So we read it as log of x to the base a. It is called our logarithmic function. Here a is clearly greater than 0. A is clearly greater than 0. Now diagram. There are two diagrams. For logarithmic function, we have two diagrams. Depending upon base. First one when a greater than 1. Second one when base less than 1. So in case of logarithmic function, there are two diagrams depending on base. Base less than 1, base more than 1. Base less than 1, base less than 1 and base greater than 1. Domain, दोनों डायग्राम को देखिए. From both the diagrams, it is clear that domain is R plus. We are getting the diagram only for positive x. There is no diagram on the negative x-axis. So we are getting the diagram only for positive x. So domain is R plus. Range is found on the y-axis. Range is found on the y-axis, and on the y-axis we are getting all the values. So range is clearly R. Range is clearly R. Okay. Now the student, do you know about this ln x? Out of these two diagrams, if I ask you diagram of ln x, can you tell me? Out of these two diagrams, which will represent ln x? तो उसके लिए पहले आपको ln x का मतलब पता होना चाहिए. ln x is what? It is called natural log. L का मतलब log, n का मतलब natural, and it has meaning log to the base e. ln x has meaning log to the base e, where e is what? E is a number having value near about 2.7. So this diagram is taken when base greater than 1, this is taken when base less than 1. So clearly for ln x we will take which diagram? For ln x, we will take first diagram. So whenever there is a requirement for diagram of ln x, remember it is our first diagram. Okay? Then type number 9, it is exponential function. Exponential function f of x is equal to a to the power x. This is called exponential function. Diagram. Diagram of exponential function. First one, when a greater than 1. Second one, when a in between 0 and 1. So as we have seen in case of logarithmic function, similarly here, two graph in case of exponential function. First one when base greater than 1, second one when base less than 1. From both the graphs, it is clear that domain is R, range is R plus. Domain is R, range is R plus. Now, if I ask you diagram of e to the power x and diagram of e to the power minus x. So, e को हम लोगों ने देखा था, e क्या होता है? E is called exponential having the value near about 2.7. So, clearly, first one is diagram of e to the power x and e to the power minus x. Second diagram is for e to the power minus x. आगे चल के सब काम में आने वाला है. डायग्राम ऑफ ई टू द पावर एक्स, डायग्राम ऑफ ई टू द पावर माइनस एक्स. आप में से कई लोगों को ई की पावर माइनस एक्स में कन्फ्यूजन हो सकता है, तो वो इधर देखें. इट इज ई टू द पावर माइनस 1 रेज टू द पावर एक्स विच इज 1 अपॉन ई रेज टू द पावर एक्स. सो इन दिस वे e to the power minus x is what? E to the power minus x is ultimately 1 upon e raised to the power x. E क्या होता है? Near about 2.7. तो 1 upon 2.7 less than 1. तो remember, in case of e to the power minus x, we have exponential function having base less than 1. And when we talk about base less than 1, we go with this graph. So, graph of e to the power x, graph of e to the power minus x, domain and range, they are same in both the diagram. So, it is about exponential function, their domain diagram, their domain as well as range. In type of function, our next type is number 10, square function. Number 10, square function. F of x is equal to x to the power 2. Graph of it. Now, from the graph, clearly you can get domain as well as range. So, what is domain? All the real number. What is range? 0 to infinite including 0. Fine. Number 11 is cube function. This is f of x is equal to x to the power 3. Dear students, square function, cube function, important is their graph. Knowingly I am telling you so that you can have knowledge of graph of x ki power 2, x ki power 3 to make problems in coming chapters. So, graph of x to the power 3. From the graph, domain is called values of x on the x-axis for which graph is possible. So, domain is all x, range is found on y-axis. Corresponding to graph, what values we are getting on y-axis, that is called range. So, here domain as well as range both are all set of all real numbers. Now, I am coming to number 12, reciprocal function. What is reciprocal function? F of x is equal to 1 upon x. F of x is equal to 1 upon x. This is called reciprocal function. Its graph So, from the graph domain. Now, students, see in this graph carefully, we are getting the graph for all the values of x excepting 0. 0 pe graph is going towards infinity. Infinity means not defined. So, this graph is defined everywhere excepting 0. So, domain is r minus 0. Then the range. Corresponding to graph, we are getting all the values on the graph, on the y-axis. But you can see 0 is never the part of y-axis. On the y-axis, we are getting all the values excepting 0. So, range is also all the real numbers excepting 0. Is it? So, types of function, number 10, number 11, number 12. Number 10 square function, number 11 cube function, number 12 reciprocal function. Now, write a note. Graph of x to the power n. Graph of x to the power n, where n is a natural number excepting 1. Will be similar to x to the power 2 if n is an even number and similar to x to the power 3 if n is an odd number. Now, student, this is an important point, will help you in coming chapters. If you need graph of x to the power 4, x to the power 6, x to the power 8, remember all will be upward parabola. You need graph of x to the power 5, x to the power 7, x to the power 9. All will look like graph of x to the power 3. That I have written. Graph of x to the power n, where n is a natural number excepting 1, will be similar to power 2 if n is an even number, and similar to x to the power 3 if n is an odd number. So, in this way we are able to draw graph of power 4, power 6, power 5, power 7, power 9 and so on. So, now students, we are moving to type number 13, which is trigonometric functions. All of you must be aware about trigonometric function: sine, cos, tan, cot, sec, cosec. So, now I am going to draw graph of all trigonometric functions and will write domain and range. So, first we have sine of x, diagram of sine of x. So, dear students, this is diagram of first trigonometric function sine of x, domain and range. So, from the diagram, domain is all x, range which is found on the y-axis, and on the y-axis you can see minimum value is -1, maximum is 1. So, range square bracket -1 to +1. Now, second trigonometric function is cos of x. This is our second trigonometric function cos of x. From the diagram, domain once again all x, all real values of x, range same as sine of x, square bracket -1 to +1. Now, third trigonometric function tan of x. I have made vertical dotted lines. So whenever graph move towards infinity, we draw vertical dotted lines. Diagram of tan of x. So here in this diagram, you will see vertical dotted line. When our graph moves towards infinity, we draw vertical dotted lines to represent graph is moving towards infinity. Now, we will write domain and range. तो स्टूडेंट्स ध्यान से देखिएगा, यहाँ पे डोमेन और रेंज लिखना थोड़ा आपके लिए टफ पड़ेगा. डोमेन कहते किसे हैं? All the values of x for which graph is defined on the x-axis, for what values of x we are getting the graph, that is called domain. Now, whenever graph is becoming infinity, infinity means not defined, those particular x we will exclude. For example, graph is becoming infinite at 3 pi by 2, graph is becoming infinite pi by 2 पे, graph is becoming infinite at minus pi by 2 पे. तो pi by 2, 3 pi by 2, may I call them odd multiple of pi by 2? अब वो हमें नहीं लेना है. So my domain is r minus 2n plus 1 pi by 2. All the real में से मैंने pi by 2 के मल्टीपल हटा दिए. कौन से मल्टीपल? ऑड मल्टीपल. रेंज ऑन द वाई एक्सिस ग्राफ नीचे पूरा जा रहा है, ऊपर भी पूरा जा रहा है. तो रेंज की अगर बात करेंगे तो graph is giving all the real values, so range is capital R. So this is our graph of tan of x. Now, number 4 trigonometric function is cot of x. Diagram of cot of x. Diagram of cot of x. So diagram of cot of x. Now, in this diagram, where is graph becoming infinite? At 0 graph is going infinity, at pi graph is going infinity, at minus pi graph is going infinity. So pi minus pi, they are what? Multiple of pi. यहाँ पे ग्राफ हमारा इन्फिनिटी हो रहा है, नॉट डिफाइन हो रहा है, तो ये हमें एक्सक्लूड करना होगा. सो डोमेन इज r minus n pi. What about range? On the y-axis, clearly graph is going towards minus infinity, on the positive y-axis plus infinity. So in this way, graph is taking all the real values. So range is all real values and domain is r minus n pi. Okay? स्टूडेंट्स इट मे बी कि मेरी स्पीड आपके साथ मैच ना कर रही हो तो मैं आपको याद दिलाना चाहूँगा, यू आर वॉचिंग द रिकॉर्डेड लेक्चर विच हैज़ अ मेजर बेनिफिट कि आप लेक्चर को पॉज कर दीजिए, वीडियो को पॉज कर दीजिए एंड कूल होके यू कैन ड्रॉ द डायग्राम. दैट्स द बेनिफिट ऑफ रिकॉर्डेड लेक्चर. नाउ नंबर 5, sec of x. So student, this is the diagram of sec of x. Once again graph is going towards infinity. Where? At pi by 2 infinity, 3 pi by 2 infinity. So pi by 2, 3 pi by 2, they are what? They are odd multiple of pi by 2. On the y-axis, clearly graph is either below this dotted line or above this dotted line. In other words, there is no graph between these two horizontal dotted line. इन दो horizontal dotted line के बीच में ग्राफ नहीं है. ग्राफ ऑन द वाई एक्सिस 1 के ऊपर है या -1 के नीचे है. सो पहले मैं डोमेन लिख रहा हूं. सो डोमेन इज r minus 2n plus 1 pi by 2. r minus 2n plus 1 pi by 2. हाउ? ग्राफ नॉट डिफाइन है पाई बाई 2 पे, 3 पाई बाई 2 पे. पाई बाई 2 का ऑड मल्टीपल, उसे रियल में से माइनस कर दिया. रेंज ऑन द वाई एक्सिस वी आर गेटिंग वैल्यू आफ्टर 1, बिफोर -1. सो रेंज इज r minus open interval -1 to 1. We are getting all the real values, but we are not getting any value between -1 to 1. -1 और 1 के बीच की कोई वैल्यू नहीं आ रही है. So all the real minus open interval -1 to 1. That is our range. Now sixth trigonometric function is cosec x. So student, in this diagram, graph is becoming infinity, where pi, 0, minus pi. Graph is becoming infinite means graph is not defined at pi, minus pi, which is multiple of pi. So domain r minus n pi. Domain are those values of x for which graph is defined. So whenever graph is going towards infinity, so all those values of x we exclude at which graph is becoming infinity. For example, here graph is becoming infinity at pi, 0, minus pi, they are multiple of pi. So after excluding n pi from the real number, we will get domain. Come to range. So as we have seen in sec of x, similarly here, there is no diagram between these two horizontal lines. Between these two horizontal lines, there is no diagram. It means we have no value on the y-axis between these two dotted lines. Between these two dotted line means minus 1 to 1. There is no value on the y-axis between minus 1 and 1. The range is same as sec of x, that is r minus open interval minus 1 to 1. R minus 1 to 1. Now students, we have our last type of function, number 14, that is inverse trigonometric function. It must be totally a new word for you. Inverse trigonometric function. Right now, I will just tell you diagram and domain and range. After completion of chapter function, we have a separate chapter having name inverse trigonometric function. There I will give you detailed idea about inverse trigonometric function. क्या होते हैं, कैसे काम करते हैं, वो सब हम अभी कुछ लेक्चर्स के बाद देखेंगे. राइट नाउ जस्ट इनवर्स ट्रिग्नोमेट्रिक फंक्शन में क्या क्या आता है, उनका डायग्राम क्या होता है, डोमेन क्या होता है, रेंज क्या होता है. As we have 6 trigonometric function, similarly we have 6 inverse trigonometric function. The first one is sine inverse x. We read it sine inverse x. ट्रिग्नोमेट्रिक फंक्शन के ऊपर -1 का सिंबल हो, दैट इज सिंबल ऑफ इनवर्स. वी कॉल इट साइन इनवर्स एक्स. डायग्राम, दिस इज डायग्राम ऑफ साइन इनवर्स एक्स. डोमेन स्क्वायर ब्रैकेट -1 to 1, रेंज स्क्वायर ब्रैकेट minus pi by 2 to plus pi by 2. Second inverse trigonometric function cos inverse x. From the diagram, domain square bracket -1 to 1, range square bracket 0 to pi. Number 3, tan inverse x. This is diagram of tan inverse x pi by 2 minus pi by 2, domain all x, all real values of x, range open interval minus pi by 2 to plus pi by 2. डायग्राम ध्यान से देखिए. ऑन द अपर साइड डायग्राम पाई बाई 2 की लाइन के पैरेलल हो गया है, टच नहीं कर रहा है. सिमिलरली ऑन द लोअर साइड ग्राफ माइनस पाई बाई 2 की लाइन के पैरेलल हो गया, माइनस पाई बाई 2 को ना कट कर रहा ना टच कर रहा. तो ऑन द वाई एक्सिस वैल्यू माइनस पाई बाई 2 से ऊपर है और पाई बाई 2 के नीचे है. Next is cot inverse x. Okay, so domain all real values of x, range it is open interval 0 to pi. डायग्राम ऑन द अपर साइड पाई वाली लाइन को टच नहीं कर रहा. सिमिलरली ऑन द लोअर साइड एक्स एक्सिस के पैरेलल हो गया, उसको कभी टच नहीं कर रहा. तो रेंज ओपन इंटरवल 0 टू पाई, डोमेन ऑल द रियल वैल्यूज ऑफ एक्स. नाउ नेक्स्ट इज sec inverse x. So students, this is diagram of sec inverse x. On the x-axis, diagram is coming after 1. On the negative x-axis, diagram is coming before minus 1. On the y-axis, 0 to pi, all the values are coming, but pi by 2 is never coming. आप ध्यान से देखो, ग्राफ pi by 2 के नीचे है, pi by 2 के ऊपर है. So domain is all the real accepting open interval minus 1 to 1 and range 0 to pi square bracket excluding pi by 2. Okay. Now we have last inverse trigonometric function, that is cosec inverse x. So this is our diagram of cosec inverse, and as we have seen in case of sec inverse, same story here. There is no diagram in between -1 and 1. On the x-axis, diagram is on the right of 1 and on the left of -1. There is no diagram between -1 and 1 on the x-axis. So when we are writing domain, we will have to exclude interval -1 to 1, because on the x-axis -1 to 1 we are not using. Now for range, on the y-axis we are covering -π/2 to π/2, but 0 is not coming. Graph is above 0, below 0, 0 is not included. So range is square bracket -π/2 to π/2 excluding 0. So these are our six inverse trigonometric function. अभी मैंने आपको बोला कि we are studying just diagram of inverse trigonometric function, their domain and range. डिटेल में इनके बारे में we have a chapter, वहाँ पे हम लोग पढ़ेंगे. So in this way I have covered all the possible types of function. We can say all known types of popular types of function. We have covered all popular type of function, and overall we have covered 14 types of function. Now student, you have to learn domain and range of all these types of function, their diagram, which we have to use in further classes. Fine? Okay, thank you.